So welcome, this is CIE May June 2010, Pure Mathematics 1, Paper 1. So there are something around 10 questions. We shall try to solve all the 10 questions over here. The first question, the acute angle x radians is such that tan x is equal to x. Then where k is a positive constant, express in terms of k, tan pi minus x. Tan pi means 180, 180 minus x. So this 180 can be written as 2 times 90. If this 2 is an even number, then there will be no change in the function. It is going to be tan x. So there are two things we need to remember. In the previous videos, I would have done that one. So a quick revision. If it is even function, when I write in the multiples of 90, when it is an even function, there is no change in the function. So if at all it is an even number, there is no change in the function. If at all it is an odd number, sine changes to cos, and if at all it would have been a cos changes to sine. Similarly, tan changes to cot and cot changes to tan. Cosecant changes to secant and secant changes to cosecant. So for the odd numbers like 1, 3, 5 and for even numbers like 2, 4, 6. So over here we see that it is 2 times 90, 2 is an even number. So there is no change in the function, means tan remains as tan. But we need to check the symbol, which quadrant is that. So for that, we quickly draw. We know that all are positive in the first quadrant, only sine is positive in the second, tan is in the third, and cos is in the fourth, ASTC. So coming to the 90 minus x, 90 minus theta, 180 minus theta, 270 minus theta in the third quadrant, 360 minus theta in the fourth quadrant. So 180 minus theta is in the second quadrant. Second quadrant sine is positive, so tan should be negative. So answer should be equal to minus tan x, but tan x is equal to k, so minus k. For example, the next one, tan 90 minus x. 90 can be written as 1 times 90. 1 is an odd number, so we know that if it's odd number, tan changes to cot x, and 90 minus theta is in first quadrant, all are positive, therefore plus cot x. But I have cot x, so it can be written as 1 upon tan x, which is 1 upon k. Finally, sin x. So for that, I first draw a triangle. Tan x is equal to how much it has been given? K. K means k upon 1. Opposite side is k, adjacent side is 1. So hypotenuse will be 1 plus k square under square root. So sin x is equal to opposite side by adjacent side, 1 plus k square. Now we know that x is acute. Acute angle means it is in the first quadrant. In the first quadrant, all are positive, so therefore it's going to be positive plus. That's going to be the answer. Coming to the second question, find the first three terms of the expansion. So phi c0, 2x to the power of 5 minus 3 upon x whole to the power of 0 plus phi c1, 2x whole to the power of 4 minus 3 upon x whole to the power of 1 plus phi c2, 2x whole to the power of 3 minus 3 upon x whole to the power of 2. Phi c0 is 1, 2 to the power of 5 is 32, x power 5, anything to the power of 0 is 1. Phi c1 is 5, 2 power 4 is 16, x power 4, negative 3 upon x. Phi c2 is 10, 8, x cube, 3 square is 9 upon x square. So upon simplification, I get 32x to the power of 5 minus 240 x power 4 upon x is x cube, and this is 80 times 9 is 720, 720, 80 times 9 is 720, x cube upon x is nothing but what? X cube upon x square is x. That's going to be the answer. Hence, find the coefficient of x in the expansion. So what was that expansion? The expansion is about 1 plus 2 upon x square times 2x minus 3 upon x whole to the power of 5. Coefficient of x. So what am I going to do it at? This expansion just now we have found it out in the first part, 1 plus 2 upon x square, and write that expansion. What was that? 32x to the power of 5 minus 240x cube plus 720x plus and so on. Now I want coefficient of x. How can I get the coefficient of x? When 1 is multiplied with 720, 1 is multiplied with 720, and is there any other possibility? 1 upon x square is multiplied with minus 240x cube, because x cube upon x square is x. So 2 is multiplied with negative 240. These are the only two possibilities where can I get coefficient of x. Coefficient of x. So that gives me 720 minus 480, which is 240. That's going to be answer for the second question. Coming to the third question. The ninth term of an arithmetic progression is 22. T9 is equal to 22. Sum to first terms is 49. S4 is equal to 49. T9 means a plus n minus 1d. 9 minus 1 is 8d is equal to 22. S4 means n upon 2, 2a plus n minus 1. 4 minus 1 is 3d is equal to 49. So 2 times 2a plus 3d is equal to 49. So I get two equations. This is 4a plus 6d is equal to 49. This is my first equation. Now second equation is a plus 8d is equal to 22. So I get these two equations. Solving these two equations, so 4a plus 6d is equal to 49. Multiply this equation with times 4, so it gives 4a plus 32d is equal to 88. Now I can subtract both. Minus minus, 4a cancels, minus 26d is equal to 49 minus 18 is equal to nothing but how much is minus 39. So minus minus cancels, d is equal to 39 upon 26. 13 is a common factor, 13 threes and 13 twos, so 1.5. So d is equal to 3 upon 2, which is 1.5. Plug in this d in any one of the equation, the first equation or the second equation. 4a plus 6 times 1.5 is equal to 49. So 4a plus 6 times 1.5 is 9 is equal to 49. 4a equals 40. So a equals to 10. So I got a value and d value. What is being asked? Find the first term and the common difference. In the next part of the question, the nth term of a progression is 46. Find the value of n. So let us add quickly a page. Nth term is 46. Tn is equal to 46. Tn formula is nothing but what? A plus n minus 1 times d equals to 46. A is 10 plus n minus 1 times d is 1.5 equals 46. So n minus 1 times 1.5 equals to 36. 46 minus 10 is 36. N minus 1 is equal to 36 upon 1.5. So n minus 1, when I take the calculator and find 36 divided by 1.5, which gives me 24. So n is equal to 25. That's going to be the answer for question number 3. Question number 4. The diagram shows y is equal to 6x minus x square and the line y is equal to 5. Find the area of the shaded region. So we have to find the area of the shaded region. So what should I be doing it out as? Find the area. Area in the sense integration of the area under the curve. Area under the curve is going to be the integral part. So I have find it out. Area is the, when I find the integration, it is area under the curve. So 6x minus x square. I want the limits. What are the limits? We don't know. but this line y is equal to 5 is touching those or intersecting those two the graph. So what do I do? 6x minus x square equals to 5. So I get x square minus 6x plus 5 equal to 0. So I do x minus 5 times x minus 1 equal to 0. So I get x is equal to 5 or x is equal to 1. So I got those 2 points as 1 and 5. So my limits are going to be 1 to 5. Now 6x integral is 6x square upon 2. X square integral is x cube upon 3 from 1 to 5. Now plug in this value. This is 3x square minus x cube upon 3 from 1 to 5. Plug in this one. 3 times 5 square minus 5 cube upon 3 minus 1. 3 times 1 square minus 1 cube upon 3. So this becomes 25 times 3 is 75 minus 125 upon 3 minus 3 plus 1 upon 3. 72 minus 124 upon 3. So 72 minus 124 upon 3 can be written as 3 times 4, then 141 will give the 123 1 upon 3. So 41 1 upon 3. So this becomes 31 1 upon 3. That is area under the graph. So this total area, which is the total area, let me show it out, this total area. But I want only the shaded part. So what should I be doing it out? So area under the graph from 1 to 5. So let me draw that one, this entire graph. I'll be getting it out, this entire one. From 1 to 5. It was not from 0. So 1 to 5, I have got this entire area. But I don't want that entire area. I want only that shaded one. So what should I be doing it out? I should be able to subtract the rectangle. Which rectangle is that? This rectangle. Let me highlight it out. This rectangle has to be subtracted. I have to find the area of that rectangle. We can see that that rectangle length is 4, height is 5. So what am I going to do it out? This value is not 31 1 upon 3. When I simplify it out, it becomes 32 upon 3. 32. 72 minus 41 1 upon 3 is 32 upon 3. Now I have to find the area of the rectangle. So area of rectangle is equal to 4 times 5, which is 20. So total area will be shaded regions area will be 32 upon 3 minus 20, which is 10 2 upon 3. That's going to be the final answer for question number 4. Coming to question number 5, the function f is such that f of x is equal to 2 sine square x minus 3 cos square x. X lies between 0 to pi. Express f of x in the form of a plus b cos square x. So f of x is equal to 2 sine square x minus 3 cos square x. I want everything in terms of cos. So sine square x can be written as 1 minus cos square x minus 3 cos square x. So it becomes 2 minus 2 cos square x minus 3 cos square x. So that becomes as 2 minus 5 cos square x. Stating the values of a and b. So a is equal to 2, b equal to negative 5. State the greatest and least values of f of x. So I got 2 minus 5 cos square x. We know that cos x maximum value is going to be plus 1, minimum value is going to be minus 1. But this is cos square x. So when I find it out the square, so what is the, and the mean value will be 0, right? So when I find it out the square, the maximum value is going to be for cos square x, the maximum value is going to be 1, and the minimum value is going to be 0 square, which is 0. So I plug in over here the maximum value of cos square x to get the minimum value, because it is minus. So 2 minus 5 times 1, which is minus 3. Similarly, I plug in minimum value of cos square x to get the maximum value, because all the beauty is because of this minus symbol. So maximum value will be 2 minus 5 times 0, which is going to be 2. So minimum value is minus 3 and maximum value is plus 2. If you don't understand this, just substitute 0 and 1. Whichever is higher, that is maximum value. Whichever is lower, that is minimum value. Easily that can also be done. Finally, solve the equation f of x plus 1 is equal to 0. So let me add a page again. He is asking in the third part, f of x plus 1 is equal to 0. F of x is nothing but what? 2 minus 5 cos square x plus 1 is equal to 0. 3 minus 5 cos square x is equal to 0. 5 cos square x is equal to 3. So cos square x equals to 3 upon 5. So cos x is equal to square root of 3 upon 5, which is 0.6. So I find the square root of 0.6. I get cos x is equal to either plus or minus 0.775. Now check the range what has been given. It is between 0 to pi. So one positive value, one negative value, both has to be taken. So from there I take both positive value and negative value. First I take positive value. Cos x is equal to 0.775. X is equal to cos inverse of 0.775. The positive value, it should be giving me in the first quadrant. So I convert the mode of the calculator into radians because it is given in radians. So it should be coming something around cos inverse of 0.775 will should be giving me 0.68. If I take the full calculator display, so don't forget to take the full calculator display, otherwise you may not be able to get the correct answer. So 0.685, three significant figures. Now I take cos x is equal to get the next answer, minus 0.775, or just now I told you that it has to be taken the full calculator display. What's that full calculator display? Better to take 0.6, otherwise you don't get the correct answer. So x is equal to cos inverse of negative square root of 0.6. So take the calculator and change the symbol and find it out. You should be getting it as 2.46. That's going to be the answer. Coming to question number 6. dy by dx is equal to 3x to the power of half minus 6 and the point 9 comma 2 lies on the curve. Find the equation of the curve. So dy by dx is equal to 3x to the power of half minus 6. So dy is equal to 3x to the power of half minus 6 dx. Do the integration. So y is equal to 3x to the power of half plus 1 is 3 upon 2 upon 3 upon 2 minus 6x plus c. Now but it passes through 9 comma 2. So plug in 9 comma 2. So 2 is equal to 2 times 9 power 3 upon 2, because over here you can see that 3 and 3 cancels, minus 6 times 9 plus c. So 2 is equal to, this becomes 54 minus 54 plus c gives me the c value as 2. So my equation of the curve will be y is equal to 2x power 3 upon 2 minus 6x plus 2. That's the equation of the curve. Coming to the second part, Find the x-coordinate of the stationary point, x-coordinate of the stationary point, and determine the nature of the stationary point. Now at the stationary point we know that the first derivative should be equal to 0. So dy by dx should be equal to 0. So what was dy by dx? 3 square root of x minus 6 should be equal to 0. 3 square root of x should be equal to 6. Square root of x equal to 2. X equal to 4. Now he's asking what is the nature of the stationary point. So what am I going to do? We know that dy by dx is equal to 3 square root of x minus 6. So I find the second derivative. D square y by dx square is equal to 3 x to the power of 1 upon 2 derivative will become 1 upon 2 x to the power of 1 upon 2 minus 1 is minus 1 upon 2 minus 6 derivative is 0. So it becomes 3 upon 2 square root of x. Now plug in this point, d square y by dx square at x is equal to 4, which gives me 3 upon 2 by square root of 4, which is a positive value. So as d square y by dx square at x is equal to 4 is greater than 0, the curve has minimum point. Minimum point at x is equal to 4. That's it. That completes the answer for 6th question. Coming to the 7th question. The diagram shows that the part of the curve y is equal to 2 minus 18 upon 2x plus 3 which crosses x-axis at A and y-axis at B. The normal to the curve at A crosses the y-axis at C. Show that the equation of AC is this much. So we have y equals to 2 minus 18 upon 2x plus 3. It crosses x-axis at A. X-axis means nothing but what? Y equal to 0. So plug in y equal to 0. 0 equal to 2 minus 18 upon 2x plus 3. So 18 upon 2x plus 3 is equal to 2. 9 is equal to 2x plus 3. 2x is equal to 6. It implies x is equal to 3. So the point A is 3, 0. Simultaneously, we will find B also. May not be required in the first part, but then also y-axis at B. Y-axis means x equal to 0. Very simple to get. So y is equal to 2 minus 18 upon 2 times 0 plus 3. So y is equal to 2 minus 18 upon 3. So y is equal to 2 minus 6, which is minus 3 minus 4. So B value is 0, negative 4. So I got A and B. But what is he asking? Show that the equation of AC. So we have to know the normal to the curve at A crosses y-axis at C. So coming back to the question, we know that y is equal to 2 minus 18 times 2x plus 3 whole to the power of minus 1. So I find dy by dx. 2 derivative is 0 plus 18 minus 1 comes front. 2x plus 3 minus 1 is minus 2. Then 2x derivative is 2. Now it crosses at A. So slope of the tangent. dy by dx means every time slope of the tangent at A. So plug in A. 36. 2 times 3 plus z 3 whole to the power of minus 2. So 36 upon 2 times 3 is 6. 6 plus 3 is 9. 9 square. So it becomes 4 upon 9. This is the slope of the tangent. But we are talking of the normal. So slope of the normal will become minus 9 upon 4. So equation of the normal will become y minus y1 is y minus y1 0 is equal to m times x minus x1. So formula was y minus y1 equals m times x minus x1. The point was 3, 0, A point, and this is m. Now, but what is being told, if we can recollect it out or scroll back and check, it crosses y-axis at C. So again, y-axis y-axis is nothing but what? X is equal to 0. Plug in x is equal to 0, minus 9 upon 4 times 0 minus 3. So I get that value, y equal to 27 upon 4. So C value is 0, 27 upon 4. What is he asking? Show that the equation of the line. So we can just find it out, the equation of the line from here. Later we can find C. Y equal to minus 9 upon 4x plus 27 upon 4. So 4y is equal to minus 9x plus 27. So 9x plus 4y is equal to 27. That is a part. But we found C. Is it C is required? Find the length of BC. Anyway, C was required, so we found B and C. So we'll find the length of BC. So let me add the page. So B was 0, 4. Was that 0, 4 B? B was 0, negative 4, and C was 0, 27 by 4. And C was 0, 27 upon 4. So we have to find the distance between these two. Square root of y2 minus y1 whole square plus x2 minus x1 whole square. So this is x1 y1 and this is x2 y2. The formula is x2 minus x1 whole square plus y2 minus y1 whole square. So it becomes square root of 27 plus 16 upon 4 whole square. So square and square root gets cancels, 43 upon 4, which is 10/3 upon 4. That's going to be distance. Question number 8. The diagram shows the triangle ABC in which A is given, B is given. The gradients of AB and BC are 2m and minus 2m. AB and BC, where m is a positive constant. The gradient of AB, find the gradient of AB and deduce the value of m. So AB's gradient was 2m, AC's gradient is minus 2m, and BC's gradient is positive m. So first we'll find AB's gradient. A is 3, negative 2 and B is 15, 22. So gradient slope of AB will be y2 minus y1 upon x2 minus x1, 24 upon 8, which is 3. 24 upon 12. So sorry, 15 minus 3 is 12, so which is 2. So but AB's gradient is m, so 2m is equal to 2, so m is equal to 1. Find the coordinates of C. He is asking us to find the coordinates of C. So what we can do, how do I find the coordinates of C? We'll find equation of AC and we'll find equation of BC. They do intersect at C and we find the point of intersection of those two straight lines. So first find equation of AC. So for that, first we need to know the slope of AC. AC slope is minus 2m and it is passing through point A, 3, minus 2. So gradient is equal to minus 2m. Just now we got m was 1, so minus 2. And the point is A, which is 3, negative 2. So equation of AC will be y minus y1 equals to m times x minus x1. So y plus 2 equals to minus 2x plus 6. So 2x plus y is equal to 4. This is equation of AC. Simultaneously, what we'll do? Equation of BC. For that, we need to know the gradient. Gradient of BC is m itself only, which is 1, and B 15, 22. B is 15, 22. So we use the same concept, y minus y1 equals m times x minus x1. So y minus 22 equals x minus 15. So x minus y equals to negative 7. This is the next equation. Now we are going to solve those two equations. So 2x plus y equals to 4, x minus y equal to negative 7. Add these two equations, y and y gets cancelled. 3x is equal to negative 3, x is equal to negative 1. Plug in this, x is equal to negative 1, negative 1, negative y equal to negative 7, negative 1 is equal to negative y equal to negative 6, y equal to 6. So the coordinate of C is negative 1, 6. The perpendicular bisector of AB meets BC at D. Find the coordinates of D. Perpendicular bisector of AB. So A and B. B was 15, 22, I remember, and A was 3, negative 2. Perpendicular bisector means I have to find a midpoint. Midpoint of AB, which is x1 plus x2 upon 2, y1 plus y2 upon 2. So which becomes 9, 10. Then gradient of AB. Gradient of AB was, AB's gradient is 2m, which is 2, but I want perpendicular gradient. So perpendicular gradient will be equal to minus 1 upon 2. So equation of that perpendicular bisector will be, equation of perpendicular bisector will be again y minus y1 is equal to m times x minus x1. So which is 2y minus 20 is equal to minus x plus 9. So x plus 2y is equal to 29. Now what does he says? He says it meets BC at D. Anywhere we found the equation of BC, we have found the equation of BC over here. X minus y equal to minus 7. So we take those two equations. Perpendicular bisector equation was x plus 2y is equal to 9. BC's equation, x minus y equal to negative 7. Solve these two equations, simultaneous equations. We can subtract these two equations, minus plus plus. So 3y is equal to 16. This was 29. So let me change it color, equals to 29. So 3y is equal to 29 plus 7 is 36. So y is equal to 12. Plug in this y value over here in any one of the equations, second equation. So x minus 12 is equal to minus 7. So x is equal to 5. So d value is 5, 12. That's question number 8. Coming to question number 9. The function f is defined that f of x is equal to 2x square minus 12x plus 7. F of x is equal to, completing square. So take 2 common, x square minus 6x. Don't touch that 7. So 2x minus half of this number every time, including the symbol, whole square, every time minus square of this new number. What was that new number? We have written 3. So 9 plus 7. So it becomes 2 times x minus 3 whole square minus 18 plus 7. So it becomes 2 times x minus 3 whole square minus 11. So remember, half of this number and square of this number, and every time it should be minus. Then second one, find the range of f. So f of x equals to, we got minus 11 plus 2 times x minus 3 whole square. We know that square term is always positive. Square term is always positive. So minus 11 plus a positive number will be always greater than negative 11. And at x is equal to 3, this value will be equal to 0. So therefore greater than or equal to negative 11. So what am I going to write? Range of f is greater than or equal to negative 11. Next, find the set of values for f of x is less than 21. F of x is less than 21. F of x is just now we got 2x square minus 12x plus 7 is less than 21. So I get 2x square minus 12x is minus 14 is less than 0. Take 2 common, x square minus 6x minus 7 is less than 0. So I get x minus 7 times x plus 1 is less than 0. So x lies between negative 1 and 7. Then g of x is defined g of x is equal to x plus k for x belongs to R. Find the value of constant k for which g of f of x is equal to 0 has two equal roots. So let me add a new page and start in a new page. G of f of x is equal to 0. G of f of x is equal to 2x square minus 12x plus 7 should be equal to 0, but g of x is 2x plus k. So 2 times of 2x square minus 12x plus 7 plus k is equal to 0. So it becomes 4x square minus 24x plus 14 plus k is equal to 0, but it has two equal roots. Two equal roots means b square minus 4ac should be equal to 0. So 24 square minus 24 square minus 4 times 14 plus k should be equal to 0. 676 is equal to 16 times 14 plus k. Then I have 676 divided by 16, 576. 24 times 24 is 576. So 576 divided by 16 gives me 36. 16 times 1, 16 times 36. So 14 plus k is equal to 36. K is equal to 22. That's going to be the answer. Now coming to the last question, 10th question. The diagram shows a parallelogram OABC. OA is given, OC is given. Find the unit vector in the direction of OB. I want OB. How do I go OB? I go O to C. Then I go C to B. So OB is nothing but what? I go O to C plus C to B. O to C is just now is same as O to C, but CB is parallel to OA. Both are parallel, so this is nothing but what? OA. So that becomes I plus 3j plus 3k plus 3i minus j plus k. So it becomes 4i plus 2j plus 4k. But he's asking unit vector, so first find modulus of OB, which is square root of 16 plus 4 plus 16, 36, which becomes 6, plus or minus 6, plus 6 I take. So therefore unit vector in the direction of OB will be 1 upon 6 times 4i plus 2j plus 4k. The acute angle between the diagonals of the parallelogram. What are the diagonals of the parallelogram? One diagonal is OB and another diagonal will be AC. So OB and AC. So I have to find AC. AC is nothing but what? OC minus OA. OC is nothing but what? 3i plus j plus k minus OA is I plus 3j plus 3k. So it will becomes 2y minus 4j minus 2k AC, and OB just now we got it as 4i plus 2j plus 4k. Now I want to find the acute angle between them. Cos theta is equal to AC dot OB modulus, because I want an acute angle. So if I dot product I find, if I get a negative answer, make it as a positive by modulus of AC times modulus of OB. So dot product 2 times 4 plus minus 4 times 2 plus minus 2 times 4. What am I doing? Multiply I terms with I terms, j terms with j terms, and k terms with k terms. So that is dot product divided by modulus of AC will be 2 square plus 4 square plus 2 square. Modulus of OB will be 4 square plus 2 square plus 4 square. Whole modulus, because just now I told that we want only the acute angle. Then 8 and 8 gets cancels. Minus 8 becomes positive 8. 8 divided by, this is 16 plus 4 20, 20 plus 4 24, 16 plus 4 20, 20 plus 4 20 36, square root of 36. So take the calculator. Theta is equal to cos inverse of 8 upon square root of 24 times square root of 36 is 6. Use the calculator, you should be getting it out 74.2 degrees. Finally, the perimeter of the parallelogram correct to one place of decimal. So perimeter means sum of all the sides, which is OA, then O to A to B, B to C, C to O. OA plus AB plus BC plus CO, all modulus. But opposite sides of a parallelogram are same. So what we can do it out is OA and BC are same, and AB and OC are same. So twice of OA and CO. CO or OC doesn't matter, because you are finding the distance modulus of this one. So 2 times of OA. OA is square root of 1 square plus 3 square plus 3 square. OC is square root of 3 square plus 1 square plus 1 square. So it becomes 2 times of square root of 19 plus square root of 11. Oh, I think so it became too big. Let me write smaller. Square root of 19 plus square root of 11. Simplifying three significant figures, 15.4. That's going to be the answer. That completes the paper. See you in the next paper. Bye.